Welcome everyone to the Midnite Power training on starting up one of the all-in-one inverters. We'll go through starting up the batteries, commissioning tests, and getting the inverter connected. And we're also going to talk quite a bit about the app and how you use that to commission an inverter. Walk through a bunch of the commissioning tests, how to use the app in the portal, how to do basic programming of the inverter. We will have another webinar where we go through all the different programming settings of the inverter. Talk about how to update the firmware via the portal and kind of just what do we see on the app and inverter screen. Also be talking a little bit about the wiring of the inverter and the programming, but we're going to cover that in more depth in some other trainings. First, we want to make sure when we're wiring it, we use the proper wire sizes per NEC and the inverter installation manual, and torque all the terminals to spec. You should have a torque wrench and a torque screwdriver in your toolkit for doing that. One thing to note on these particular terminals that we have on the breakers is they are a box terminal that sometimes looks like it's ready for a wire to go in there when they're fully tightened, and they come from the factory fully tightened, so they don't rattle loose. So you got to make sure you open them up and you'll see that box kind of move down and actually open up to put a wire in there. We've had some people comment that it seemed like they had to turn the screw counterclockwise to tighten on the wire, which means it's trapped between the plastic and the bottom of the wiring box, not in the actual box that's supposed to be clamping the wire. So just something to be aware of on these breakers. Here's kind of a view of the inside of the inverter. We've got our battery breaker and our battery input on the left, our main 100 amp AC input and output on the right, and then all of our smart loads and additional load breakers. And down on the lower left, we've got our PV inputs, 2 input terminals for each of 3 different MPPTs, and then our neutral and our ground bus bars for our AC, and then all of our communications boards. Now, one thing to note is that all the communications are behind a lot of our big AC wires. So we really want to think about wiring our communications first before we run all our big wires in. That's kind of the backwards of the way we like doing it. Usually it seems like we always want to put the big wires in first and then go to our small cables. But if we put all of our communications in there first, it'll be a lot easier. Same with our PV wires. They sometimes end up being behind some of the other cables if we can put those in there first. Here's what it looks like all wired up. We've got our main battery cables. We really want to use 4-aught wire for this. Had a lot of issues with shutdowns and problems under surge loads, people using 2-aught cables. This inverter really wants full voltage, and it can pull over 400 amps under surge loads. So 4-aught battery cables, don't undersize those. We've got our toroid on the battery cables that helps smooth out ripple and reduce noise. Our PV wires, those are maximum of 8 gauge wire. And our AC connections, one thing to note is all of these breakers are only rated for copper wire. I know a lot of people's inclination is to run aluminum SCR cable in and out of the inverter, but the breaker terminals are not rated for aluminum wire, so something to think about. And if you're doing full power, if you're doing off grid, this can be different, but connected to the grid, this is a full 100 amp pass through. So you want 2 gauge copper. Don't want to have undersized cables here. And also to note, we've got a toroid on our DC grounding electrode conductor That's our AC wire going back either to our ground rod or our UFER or back to the AC service. If you really want to work on noise control, some people who are ham radio operators have had to put toroids on all of the ground wires as well as the snap-on ground chokes to really kind of calm it down. And also using metal conduit for all the wires entering and leaving the inverter, not PVC conduit, helps with the noise if you're in a, say, a ham radio type setup where you really want to reduce the noise. The app and the portal, those are going to be our main ways of communicating with this inverter and programming it. Essentially, we have 3 different ways that we have control and monitoring and programming of the inverter. 2 of them through the app and 1 through the portal. So we'll go through each of these. The app has a Bluetooth connection directly to the inverter locally, and that's how we start our programming, and we can do the entire programming except for a couple things through the app and a Bluetooth connection. We can also use the app remotely. The inverter has to be connected to the Wi-Fi or the local area network to be able to do that and connect it onto the server. The service portal also goes in remotely once we've got the inverter connected to the server, and it can do most of the same functions. There's a few things that are particular to a particular way of connecting to it. We can only initially connect it to the Wi-Fi and set the time on the inverter with the app via the Bluetooth connection. So that's kind of like the minimum we need to do on site is get it connected to the Wi-Fi and set the time. We can only create an end user and register the inverter on the portal either through the portal or remotely through the app. That's not something you can do when you're connected via Bluetooth. So sometimes, say the person installing it might get it connected to Wi-Fi, and then the office will do all the rest of the programming and create the end user and all that kind of stuff. Or you can just switch to using the app remotely. You can be connected to the same Wi-Fi as the inverter, just not connected through the Bluetooth, and you can do all that on site. There's one thing, upgrading the firmware, that you can only do from the service portal. You can also upgrade the firmware with a laptop and a direct connection to the inverter, but we're only going to cover upgrading it through the service portal today. Both the app and the portal have both an end user level and an installer level, and there's different things you can do depending on that. When you connect via Bluetooth, you're always going to connect as an end user initially, and then you need to click the little gear icon and enter the installer level password, which is super admin, to get into the installer level to be able to actually do most of the programming. You can connect it to the Wi-Fi and set the time via just the end user level Bluetooth access. You just can't do any of the other programming. For the app, either logging in remotely or the portal, you'll need an installer account. The username and password for these are both case sensitive. The end user account is generated when you register the inverter on the portal. You link it to an end user and that generates the end user account. We'll go through this. The installer account you need to get from your distributor. So for the portal, it's actually 2 different websites you log into. The installers, it's service.midnitepower.com, and for end users, it's view.midnitepower.com. These are the same credentials that you use for logging into the app remotely, and it's just what things you have access to depending on which level of login you have. End users have the ability to change some of the smart loads, the reserve capacity, Adjust your time-based controls and adjust the Wi-Fi connection and tell it to charge up from the grid, because those are the type of things that you might need to adjust as the end user. But a lot of the other set points for more of control of the inverter are not adjustable as an end user. You'll need an installer account to do all those setups. So for the app, you'll want to download it from the Apple App Store or Google Play. Search for Midnite Pro, and it should show up looking like it does right here. Make sure when you're installing it that you give all of the permissions it asks for Bluetooth access and the camera and location. I don't know why it needs location, but it definitely needs Bluetooth, and the camera it uses to scan the barcode and connect to it that way. Bluetooth has had a lot of issues with older Android and Samsung devices. This isn't just our app or our inverter, it's a lot of Bluetooth issues apparently. I've been unable to get my Samsung equipment to connect to it, but I've had no issues with iPhones connecting. So that's something to be aware of, especially if you've got older Samsungs. It seems to be an issue. And you'll want to get an installer account from your distributor, like I said. So we've got our app loaded on our phone. We're ready to turn it on. Make sure we've got all the tools we need ready. We're going to need our digital multimeter to check things and our smartphone or tablet with the app. The app also runs on MacBook computers, I found, although it's in the iPhone settings, so it's kind of reduced size, but it's the same app, will run on a MacBook as well. Start with all of our breakers off, our PV inputs off, our AC breakers are off, our batteries are off, everything's off when we start. First thing we're going to do is turn on the battery. We want to verify our COM wiring. We've got kind of two different levels here. One is the link between our different batteries if we have multiple batteries. And then the other one is our CAN bus going between the master battery to the master inverter. So our master battery, that is the battery that only has a link out going to another battery. It doesn't have any link into it. And that's what determines the master battery. And that's the one we need to plug that CAN bus into from the inverter. A lot of the older battery manuals have this indicated incorrectly, that you can plug the CAN bus into any battery and it becomes the master. That's not correct. The placement of the link out and the link in cables is what actually determines which is the master battery. And then the CAN bus has to plug into that battery. So the last battery will only have a link in connected. The ones in the middle of the chain will have a link in and a link out. And then the master will only have a link out. You want to turn on the breakers for all the batteries. And then you turn on the master battery. You press the button for about 3 seconds and release it. And the bar graph will light up only on the master battery. The run light will be blinking on all the others, but there's no bar graph on them, and you don't want to touch any of the other power buttons. If you touch the other power buttons, you'll actually be turning them back off. So the master battery, when you turn it on, it'll turn all the rest on, and seeing the run light on the rest of them, but not the bar graphs on, lets you know that it's properly stacked and the battery's working. Here's kind of showing what you see on a properly operating system. You see the cables going from the link in to the link out. These are the rack mount stack batteries, and it looks a little different on the wall mount batteries, but it's essentially the same methodology. You can see we've only got our bar graph active on the master battery up here, which has our CAN cable going off to the inverter. Now we want to measure our battery voltage. Take our digital multimeter and measure the voltage at the battery input terminals on the inverter. Verify our polarity. Make sure we've got both the polarity and appropriate voltage there. And now we want to turn on the battery breaker in the inverter. It'll power up in standby mode. It says off on the display, but the display and the indicator lights are on. So usually when we're saying the inverter is off, it's actually in standby. Um, Completely off is with the battery breaker off and all power off, and there's nothing on the display. But standby is where we do all of our programming, and it does say off on the display, but the display is on. While we've got our multimeter handy, this is a good time to check and make sure our DC PV voltage and our AC grid voltage are appropriate. The PV disconnect and the breakers should still be off, but we can check and make sure we've got the right voltage coming in from outside. Here is a trick on measuring the PV voltage. Those little holes right above the orange flip lever there, that is where you can stick your multimeter test lead to measure the PV voltage coming in. So I've heard a lot of people say there's no way to measure the PV voltage with that terminal because there's not a screw on it, but there is a test point on there. So you can stick your test leads in there and verify you've got the correct PV voltage. Also, you want to verify that you have the right, that they're floating, that they're not grounded on either the positive or the negative. This is especially a problem if you're reusing older arrays that may have been grounded somewhere or may even have ground faults up on the roof from squirrels chewing off wires. This inverter does not like ground faults, especially multiple ground faults can be a problem. So anytime you're reusing old arrays, especially, and even with new arrays, it's good to check. Make sure that you have the both positive and the negative floating. Usually what you'll see when you measure from ground to negative is like a high initial voltage and then it quickly goes down, but it's not stable at like 0.0. Then you do the same thing with the positive to ground, you'll measure the same thing, kind of maybe 100 to 50 to 100 volts initially, and then it quickly goes down to like 0.6 and it's bouncing around a little bit. If you have a nice steady reading, either high voltage or steady reading of 0.0 or 0.1, that means somewhere there's a connection to ground and you need to find that before turning on the PV switch. If you have rapid shutdown on your PV array, remember you may not be measuring the full PV voltage. You often get 1 volt for each of the RSDs. So if you've got, say, 10 of them in a string, you'll measure 10 volts. Check the manual for your particular rapid shutdown system for how you test for proper output before it's activated. Now we're going to open our app and we click local access up top. There's no account name or password needed for this stage. I'm going to scan for inverters, and if you don't see any inverters, it's usually a Bluetooth issue. Make sure you've enabled Bluetooth, and if it's a Samsung device, there's a lot of stuff on the internet on how to make Samsung Bluetooth work better. I've not had much luck with it. You want to select your list of inverters and connect to your inverter. And this is what you'll see. You'll see a little graphic showing the power flow and showing wattages to various things. And up at the very top, you'll see any warnings or faults that are currently on the inverter. If we scroll down, we'll see some graphs for our solar info, what it's doing, and keep scrolling down. We've got energy settings, equipment maintenance, logs. We'll kind of talk about all of these and switch to a different inverter. If we swipe right, or swipe left, I mean, it will bring up the current status of the inverter. And we can see we've got our Wi-Fi connection, our Bluetooth connection, a bunch of info on the inverter, what the serial number is, what the current firmware what the solar is doing, what the battery's doing, what the grid's doing, our AC, normal load, AC coupling, all basically the total of what's going on with the inverter right now. First thing we want to do when setting up the inverter is go to the equipment maintenance screen, and we want to sync our device time with our phone or tablet. Also in this section, we have reset, clear all data, and the inverter on and off. If usually it's fine to just start and program our inverter, but there's times when we want to clear all the data, especially if we've got a lot of stuff set up incorrectly to begin with. We can get some weird data points that throw off all the graphs. Like one thing it does sometimes is saying it's got like gigawatt hours of production, which doesn't make any sense for this size of inverter. So once you get all the rest of the settings where they're correct and there's no errors, especially like CT settings and such, it's sometimes a good idea to then go in and clear all the data so it can start out good from good settings and not have some bad data there at the beginning of it. Reset resets everything to the factory defaults. If you've gone through and you've changed a whole bunch of stuff and you're just not sure what you've changed and it's just not working right, sometimes going back to the factory defaults is a good place to get you back to where you know where you're starting. We want to go through and connect it to Wi-Fi now. This is under settings and communication. Couple tricks here. It has to be a 2.4 gigahertz Wi-Fi and it has to have a password. It won't connect to open networks and it won't connect to a lot of the kind of 2.4 or 5 gigahertz mesh signals that some of the newer routers put out. I've heard that the new Starlinks do that and you can't turn off the 5 gigahertz side. So in that case, you may need to look at hardwiring it or doing some sort of Wi-Fi adapter rather than connecting it directly. Another thing we have had issues with is routers that are programmed to prevent connections overseas, especially to China. The server that it's connecting to is actually in the US, but for some reason, it's a Chinese company that runs the server, and some routers prohibit connection to that server. So it'll connect to the Wi-Fi fine, but it'll never connect to the server because of that. So just some issues there. We also have a LAN port on the Wi-Fi dongle if you want to hardwire it to the internet. Remember, if you're connecting via hardwire, that's a potential place of lightning to enter it, and you want to have some surge suppression on that Cat5 cable if it's coming, say, from a different building or something. Now that we've kind of gone through the overview and gotten it connected to the internet and set the time on it, it's time to program the inverter. We can either continue doing this via Bluetooth, or we can connect remotely and get the inverter set up on the portal and do all the programming there. We'll talk about how we get it on the portal in a minute if you want to wait till you have it on the portal to program it, or we can program it through Bluetooth right now. And like I said, we have a whole nother webinar on all the different programming options and how to set it up to do what you want to do. First, we want to go in and program the battery settings. We want to set our battery type and our battery parameters. For Midnite batteries, default will be Pylon, which kind of talks to the Midnite batteries, but it's better to set it to Midnite. And then everything, all the defaults for communications protocols will all be correct. We want to set it to use state of charge when we're talking to Midnite batteries or any closed loop connection. If we're doing voltage control, we want to set it to voltage instead. We want to set our minimum discharge and maximum charge levels and rates and everything. Um, Again, we'll discuss this more further in a different webinar. One important thing to do in this initial setup is go underneath grid settings and set up our startup time, our first boot time, and our reconnect and boot time. Because otherwise, when we hit that on button, either the physical button on the side of the inverter or the on button in the app, it will count down from 300 seconds, which is 5 minutes, before it turns on. We can set that as short as 10 seconds, and it's a lot less frustrating when you're trying to turn on the inverter and sitting waiting there for it. Don't change any of the other settings in the grid if you're actually connected to the grid. If you're doing things like using a big generator on the AC input instead of grid, or in a lot of the island grids, you will have to adjust some of these settings. But for general US mainland grid, don't change any of these settings. For power control settings is where you set your work mode, whether we're doing off grid or self consumption, whether we're supporting normal loads, how our sensors, CT sensors are working, whether we're doing zero export. We also have our settings for time of use metering and our smart loads underneath power control. That's where most of our settings are, but not all of them. And once we're in the portal, we can upgrade the firmware if required. If we are off grid and we don't have good, reliable internet, we can also upgrade the firmware using a computer and an updater tool. It's a bit more involved. I prefer doing it on the portal if possible. And you'll want to check with your distributor for what is the latest recommended firmware, because we are still doing new versions of firmware, either to correct issues, improve functionality in different areas, and also add improved functionality in the future. We're looking at a bunch of improvements for the time of use operation connected to the grid, especially, and maybe more control and smart loads, better generator integration, a lot of different things that we're working on releases of better firmware. So depending on your particular use case, the firmware that it comes with might be fine, or it might really work a lot better with an upgraded one. So check with your distributor or with us on what is the latest recommended firmware for that particular application that you're using it for. So now you're actually ready to turn on the inverter. You turn it on either the button on the app in the equipment maintenance screen, or push the button on the left side for a few seconds till it beeps, and it'll count down. You'll see it in the lower right corner of the screen on the inverter, counting down from 10 seconds to 0, and then it'll click and turn on. You'll hear the fans come on. Measure that you've got your proper AC voltage. Measure it at the top of the AC outbreaker first, and measure that it's all correct, and then turn on your AC outbreaker, turn on your AC inbreaker, turn on the PV switch, and then verify that everything is doing what it should be doing. Now we need to create an end user account on the portal. We can either do that as soon as we've got it hooked up to the Wi-Fi, or we can do that later. But to be able to use the portal, we've got to create an end user account, because every inverter is tied to an end user. So this end user account is created by, yeah, that's correct. So the end user account is created by the installer to register the inverter. We're going to go through that process. Something to know about that is that that end user account, you can either set it up with, say, one of your emails just to get everything going, or with the customer's email. It'll automatically send an email out to that email that you put in there when you make it. And right now, it's not possible to change that email, and it's only possible to have one end user account per inverter. So, like, you can't make different end users for different people to log in and see it. It's like one end user account, and they can share that login amongst lots of different devices. Like, you can have access to that login and then give it to the customer, but you can't like make different end users for like the husband and the wife and the kid and stuff to look at what the inverter is doing. It's just one account with one username and login. And once you've got your installer account, which you get from your distributor, then you as the installer can log in and make the end users and register the inverter. So on your app, you're going to log in to the account name and password using your installer account, and then hit the sign in for remote access. So you'll still see your local access via Bluetooth, and then you'll see a list of inverters, and then in the middle, you'll see create an end user. So this is where you're going to want to register the inverter and create the end user. Now there's a little bug here. If you hit create an end user and don't follow through in actually doing it, the app won't let you cancel back out of there, and you'll have to uninstall and reinstall the app. You can just kind of make a fake end user account that you later delete to get through there, or you can uninstall or reinstall the app if you accidentally hit that when you're not intending to make an end user. You'll want to enter the end user name, the email, the time zone, and then if you click on the little symbol there and the serial number, it'll open up the camera and you can scan the serial number barcode on the inverter. That's the serial number one, not the QR code on the side of the inverter, but the actual serial number one. You can also manually enter that serial number by typing it in which case you want to type it in full with the dash and the PH on the end. If you have multiple inverters on the site, you'll want to add the first one when creating the end user, and then go to the list of users, and you'll see the option for adding more inverters to the plant. Say you have stacked inverters for multiple setups. Once you've created that end user, it'll show up on the app remotely and on the service portal. The service portal is really all the same stuff as the app, but it's got a couple more things it can do. You can upgrade the firmware, and you can download data for what the inverter is doing in CSV format and such. When you log in, you'll kind of see a screen like this, and you'll see all the different end users that you have registered to you. You hit end user management over here, and that'll give you all the end users. If you click on the little gear icon, it'll go to that inverter. If you have multiple inverters on a system, you don't have a gear icon. You have to click on the end user name first, and then you'll see the multiple inverters under that end user. And it shows whether it's normal, faulted, standby, or offline. We're programming it, we want to scroll down and hit this button here for remote setting, and that will bring up a screen which allows us to actually program the inverter. So when we're programming the inverter through the app, changes occur right away. When we're programming it through the portal, here's what it looks like. You'll have in the lower right corner a read and an upload button. When you first open this box, you want to hit read so you can see what's actually there now. Sometimes it'll have old data from last time you were working with this inverter. So you always want to hit read first, and then once you've made the change you want, hit upload to send them to the inverter. It's not automatic when you make the change. And when you're programming the inverter remotely, especially, you need to be patient. Sometimes it can take several minutes for these changes to take effect. And if you just eating it, it can cause a data jam, and then the whole inverter will lock up sometimes for quite a while, like half an hour. So just be patient and give it 5 or 10 minutes to change what it's doing after you've changed the settings. It's not instantaneous all the time. Um, One thing is when you're going through these different tabs across the top, you got power control, battery. Each of those needs to be read and upload separately before going to the next one. So you can't read, then go through a whole bunch of stuff and then hit upload. You want to go through each of these tabs, read it, and then upload it when you're done programming it. Upgrading the firmware is also done from the portal. And that's this button here, upgrade device. If we click on that, it'll bring up this little box on the right here, and it'll show us what our current firmware is. The MDSP and the CSP, those are kind of our two main numbers we're looking at. And then BMS is the firmware of the batteries. If it's currently 406 or higher, we can upgrade it in one step to the current level. And if it's an earlier version, we'll have to do it in multiple steps. Right now, the current stable firmware that we're running is 606 and 611. Unless you're running lead acid batteries, we do have a different one for those, which has some improved controls for lead acid batteries. Currently, the firmware is 523 for the PowerFlow 16s and 521, although I think there is a new one, 525, coming out shortly. So maybe ask us what the current one is for that. So when we're upgrading the firmware, we want to do the master DSP first, and then we'll do our CSB, and then we'll do our battery third. You'll see a bunch of different firmwares in here. Generally, we just want to do the 606, 611, and 523, unless you're recommended to do something different for your particular case. Because the inverter shuts off during the upgrade process, it's always best to just put it in standby first. It's not good to have it suddenly shut off while you're doing the upgrade. And every once in a while, it can actually cause some really bad things to happen. So it's best to always put it in standby first. Then the issue is you need the internet to stay up while you're doing this. So if you're off grid, you need to have a little UPS for the internet, keep the internet on while the system is doing its upgrade. And it may take 20 or 30 minutes to do a full upgrade process. It's not something you do very often, but it's not something that's really quick either. It'll go through its thing and you just wait for it to go through and it'll say done, and then you move to the next one and then do that. And then the third one for battery upgrades if necessary. If it's not at least 406 currently, you have to update it in 2 steps. So you have to first go through these 3 that are marked V3 to get it up to 406, and then you can upgrade it to the current one. And this one, it absolutely has to be in standby before starting, or it can actually blow out some of the transistor boards if it upgrades from a version 3 when it's not in standby. For stacked inverters, it has to be placed in standby, and all of the inverters have to be updated before turning the system back on. Batteries are always updated through the master inverter, not separately. If you're using batteries without a Midnite inverter, there is a different procedure for updating the battery firmware with a computer cable connection and special software. But when you're using it with the Midnite inverter, they're just done through the master inverter. If you have a battery system with just one battery, it needs to be in standby with either PV power or AC power to the inverter before updating the battery, because the battery will turn on and off during the process. If you have a system with multiple batteries, you can update that while it's running because it'll only turn them on and off one at a time, but it's best to avoid any heavy loads while you're doing that. And then finally, just to go through the display on the inverter, there's a PDF on the shared folder, which is this. Sometimes this can be useful to print out and stick on the wall next to the inverter for the customer to see. What do all these different things mean? Essentially, it's just telling you what is the inverter doing. We've got warnings in the upper right corner. It'll give a little code for the warning. Got what mode it's in, what our date and time is, whether we've got our Wi-Fi connected, kind of some gauges of how full our battery is, how much solar production we're getting, how much load we're selling to the grid, how much is going to our backup power. And then kind of in the lower right corner, that cycles through just how much power is going through a bunch of things. And then in the lower left corner cycles through what is our battery, what is our PV, things like that. I generally use the app for most things, but it's nice to just be able to quickly look at the screen and say, oh, my grid is off, or my generator should be running, or I've got about half power on my half state of charge on my batteries without having to pull open the app. But the app is really a lot more info. And what a lot of people have actually done is get a tablet and just screw it to the wall right next to the inverter as kind of a display screen. Um, just like a lot of other inverters have a separate display screen, you can use any tablet as a display screen for this one and just have it sitting on the wall next to the inverter connected to it. And that is it for this presentation. Please email us with any questions or anything, and we will see you next week.